Geometry, Unit 4, Lesson 6. I can develop a method to solve for distance and midpoint on a coordinate plane. So let's figure out the distance first here. CD means the distance from C to D. I'm just going to count. This would be 1, 2, 3, 4, 5, 6 units. Distance from C to D is 6 units. Okay, well I can do that over here too when there's two number lines. But it has to get a little bit more complicated. So we're going to talk about a graphical way and a formula way. Here's the graphical way. I'm going to plot my points A and B first, and then I want to find the distance from A to B. Okay, so A is -1, 2, and B is 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, 6. And if we want to find out the distance here, how long that is, what we actually have to do is build a right triangle. So if you take a look, I can build the triangle this way, and this is 1, 2, 3, 4, 5, 6 units long this way. And this one here happens to be 4 units, 1, 2, 3, 4, this way. And it looks a lot like slope, and you'd be right. It's just that there's no positive or negative because distance is always positive. 6 units long, 4 units long. Why did we do that? Because this is a leg, and this is actually the hypotenuse. And this makes a right triangle. So if you want the hypotenuse right here, what you're going to end up doing, it's really a squared plus b squared equals c squared, but I just switched it around on you. C squared equals a squared plus b squared. I don't know the hypotenuse, but it is the distance from A to B squared. Now my first leg is 6 squared, and my second leg is 4 squared. I pulled them right from there. Next up, let's go ahead and simplify. AB squared is equal to 36 plus 16. If I finish up here, 36 and 16 is 52, but I don't want AB squared, I want AB, so I'm going to square root both sides to undo the squaring, and I get AB equals square root of 52. Are you done? Nope, you need to reduce. So you might have to go off to the side and use your laws of laws of how we reduce radicals. And 52 is pretty tricky, but if you try and break it apart, you're actually going to see it's 4 and 13 that makes it work. That's pretty tough. So I want square root of 4 times square root of 13, and the distance from A to B is going to be 2 square root of 13 units long. That's how long this is. Do not pretend to count. 1, 2, 3, 4. You can't count this way. You can only count either horizontally or vertically. So don't count. You have to use a right triangle. Now, some people might say, all right, then is there another way to do that, but with a formula? And it's the exact same setup. Your a squared plus b squared, it does equal to c squared, which is the hypotenuse. So here, look what I did though. I took this and I just square rooted both sides right here. It knocks this out, leaving just the hypotenuse, or in this case AB. And then I have my a squared plus b squared, or rather leg 1 and leg 2, underneath the square root. And this is your formula. Except there's one small difference. And this is the hardest part of the whole lesson. How do you figure out how long these legs are without having to count? 1, 2, 3, 4, 5, 6. And the answer is this. This is a little tricky, but take a look. If you look at the coordinates of these points, B is 5, 6, and A is -1, 2. And the way you figure out that this side, for example, is 6 units long, look at how this x-coordinate up here, the second one, and this x-coordinate down here, the first one, if you do 5 minus -1, you get how long this is. Again, this is 5 right here for x. Well, so is this. And so if you want to figure out how far apart this is, you do 5 minus -1. And in doing that, look what ends up happening. If you do 5 minus -1, you get 6. So what you're really doing is you're taking the difference in the x coordinates. To get the y, you want to do 6 minus 2. That's just 4. Again, this is 6 high, this is 2 high, leaving 4 if you subtract the two y coordinates. This is my y2, this is my y1. And it doesn't matter if you call this x1 or this x1. So I'm going to go ahead and put y2 minus y1, and then we can go ahead and substitute. My x's happen to be 5 and negative 1. And my y's happen to be, if I were to come in here, I could say my y's are 2 and 6. So I'm going to do 6 minus 2. And you might say, what happens if you reverse them? That's okay, because anything squared comes out positive. So for example, 5 minus minus 1, that's 6. 6 minus 2 is 4. But if it had been 2 minus 6, you'd get negative 4, right? But what's negative 4 squared? Positive 16. What's 4 squared? Positive 16. It doesn't matter. It works out just fine. And you can see you get to the same spot as we did over here, where we got square root of 52 as our answer. We still need to reduce it, and we would reduce it the way we did over here to get to square root of 13. So again, the difference in the x's gets you how long this leg is, and the difference in the y's gets you how long that leg is. You can go ahead and try these yourself. I'm going to go ahead and switch on over to the midpoint now. And before I do that, I'm actually going to give this one more look. You can try this one on your own, and I'm going to do it right now. T is negative 2, negative 3. C is 2, 1. Go ahead and build yourself a right triangle. And you can count 1, 2, 3, 4. 1, 2, 3, 4. So c squared equals a squared plus b squared. You're going to go ahead and put your hypotenuse in. That's over here. That's TC. And that's equal to 4 squared plus 4 squared. This will be 16, and this will be 16 to make 32. And then we'll go ahead and square root both sides. TC is equal to square root of 32, which is square root of 16 times square root of 2, which is going to be 4 square root of 2. That's going to be the answer for how long this is, 4 square root of 2. If you were to use the formula, C is 2 comma 1, T is negative 2 comma negative 3. So I'm just going to go ahead and I'm going to look at my x coordinates. And these will be my y coordinates, the up and the down. And I'm going to go ahead and write my formula over here. The distance is equal to the difference in the x's and the difference in the y's, each squared. We're going to add them up. This is just a squared plus b squared, but I get how long this leg is by taking the difference. Here I go. My distance in this case is TC. I should call this TC. And the hardest part is the substitution, and then you're good to go. So for me, I'm going to go negative 2 and 2. So do negative 2 minus 2, and then I'm going to do negative 3 and minus negative 3 minus 1. Negative 2 minus 2, negative 3 minus 1. Okay, I kind of did a little x2, y2, x1, y1. I switched from the last one. Doesn't matter. This is going to give you negative 4 squared. This is going to give you negative 4 squared. That's 16 plus 16, or square root of 32. And you're back to where you were before. And we get the same thing. The formula, when is it better? Rational numbers, they're not nice integers, or if these are really far apart. Okay, the last thing happens to be the midpoint. If I ask you to find the midpoint of this line right here, well, let's see how far it is. 1, 2, 3, 4, 5, 6. So halfway, the middle would be 1, 2, 3. Right here at negative 0.5. That's the midpoint. halfway. We're going to do a similar idea down here. So we're going to stick with the same points. A is negative 1, comma 2. B is 5, 1, 2, 3, 4, 5, comma 1, 2, 3, 4, 5, 6. And if we want the midpoint, what we're going to do is we're going to go ahead and do it a graphical way, which is, yeah, make a right triangle. This is kind of cool. And then make another right triangle on the other side. And just sketch in that other diagonal. Be as accurate as you can. And where they cross, that's the middle. It's kind of nice. Because when you make a rectangle, don't the diagonals bisect each other? And doesn't bisect mean the midpoint? Perfect. So this is 1, 2, comma 1, 2, 3, 4. This is 2, comma 4, and that's your midpoint. Midpoint is 2, comma 4. Now that's really nice, of course, until you get not very nice numbers, or maybe they're really far apart. So what we'll do is we'll realize there's another way to do this. I'll just use the points over here. Here are my points. And the way you figure it out is you want to get the mean of the x-coordinates and the mean of the y-coordinates. So what I'm going to do is I'm going to go ahead and put in, there are my x's. Oh, forgive me. This should have been the other x. There it is. We're adding the x's up. Here are my y's. Y and y. They're both going to go there. Okay. So let's substitute in negative 1 and 5. And then we're also going to do 2 and 6. That's going to be 4 over 2. This is going to be 8 over 2. And this is 2, comma 4. That is the midpoint. Just like we found before. You take the mean of the x's and the mean of the y to get the coordinates. So you can go ahead and try this one on your own. Plot negative 2, 1, 2, negative 3. There's t. 1, 2, up 1. That's c. Go ahead and make your right triangles. Sketch in the other diagonal. And you can see that the midpoint is right here at 0, negative 1. Or, let's use the formula. The midpoint coordinates are equal to the mean of the x's and the mean of the y's. So I'm going to go ahead and substitute in. Here are my two x's. I'll put here and here. I'll put negative 2 plus 2. And then my y's are negative 3 and 1. That's 0 over 2. And this is negative 2 over 2. Making for 0 and negative 1, which is exactly what we had over there. Last one, a little confusing. Instead of me asking you for the midpoint, I'm actually asking you for the coordinates of the end point. So let's see. I'm giving you the midpoint, and I'm giving you one of the end points. I'm going to give you n out of nv. So n is negative 1, 2, 3, 4, comma 1. And m is negative 1, comma 0. Question is, where is v? Well, if m is the midpoint, here's the graphical way to do it. Just take a look. I come over 1, 2, 3, and then I come down 1. Do the exact same thing. Go over 1, 2, 3, and come down 1. And that puts you right at the other endpoint, v, which is 2, comma, negative 1. Or, if they're not very nice numbers, they're not integers, or they're far apart, last thing we'll do, we're going to use the exact same formula, except this time, so the x-coordinate, okay, I already have, and here's the y for my other endpoint. Oh, that's the answer, excuse me. I'm going to put in, for the midpoint, -1 for x, and it's equal to x1 plus the other x is -4. And here's the y coordinate over here. 0 is equal to the y1 plus the other y coordinate 1. Let me back this up and see if it makes some sense. So I broke things apart. I took this midpoint x coordinate, but that's the answer. It goes over there. And here's the other x coordinate. I put it right here, and I'm looking for the final other endpoint coordinate for x. And I'm doing the same thing for y. I took the answer of the midpoint coordinate, put it there. And then I took the other y coordinate and put it here. And I'm looking for the missing one. So you just have to solve both of these. And the way you do it, you want to do the division of 2 with a multiplication of 2 to both sides. How do you undo a -4? Let's add 4 to both sides. And you get 2 equals x1. Over here, I'm kind of splitting this up. I'm going to multiply both sides by 2. 2 times 0 is 0. I'm going to take away 1 from both sides, and I get y1 is -1. Therefore, x is 2. This is -1. This is the other endpoint. So there's your formula, and make sure you either take a graphical or algebraic approach, whatever you feel most comfortable with. Good luck.